Hey guys, and welcome back. I noticed that in the last video I didn't go over some of the material with enough some visual representation, so I decided to go through one more time and show you guys what I meant by binary bits, nibbles. I think could have got a bit confusing, but if you already know the material, you can skip this video. So to start off, I want to talk about a bit binary, and what binary pretty much is a way of counting either zeros or ones. That's how we use on it, zeros and ones. And we often use it to represent memory, or what's stored inside of memory, because all of memory contains some switches that's either on or off, so that's perfect for binary. So a normal computer for a really long time, we always have been representing a byte of memory, which corresponds 1, 2, 3, 4, 5, 6, 7, one more, 7 and 8. So there can correspond of 8. Oops, misspelling byte. Here we go. So here it is, a byte. They correspond 8 sequence of zeros and ones. Let me change color over here. I'll put this as red. So, oh, it's not a. Let's see, 1 0 0 1 1 0 0 1. So that's a byte, and that is pretty much the standards of all computing nowadays. It has 8 bits, and what a bit is pretty much just either the value 0 or 1. So a bit pretty much either has the value either the 0 or 1. Put 1 here for per. And the next thing up is the change colors, is the Nibble. And what a Nibble pretty much is a 4 bits instead of a complete 8. It's 4. And I'll put some numbers here. 0 1 0. So what a bit is useful for is for actually storing hex, because the max value that a Nibble can have is actually 15. So if you go through all the possible numbers like you saw in the previous videos, 0 0 0 0 is 0, and 1 1 1 1 it's f of the value 19. So that's why I was referring to a Nibble. And let's go to showing you guys how to the actual rules. So a decimal, if has only these characters over here, 0 through 9, that's a base 10. What the computer uses is the binary system. Change colors. Binary is from either 0 or 1. The next thing up we have is the hex, or hexadecimal. Hexadecimal, it corresponds to 0, 1, 2, 3, 5, 6, 7, 8, 9. Then A A, B, C, D, E, and F. And for the sake of learning, there's also octo. Put green. Octo, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, 7 is choose per parts. Oh, just 7. It's and how they work is pretty much all the same. So if I have the decimal system, let me put it over here. I go 0 through 9, then 9. If I gonna go accounting higher than 9, I'm pretty much gonna go to the next number. So it's 0 and 9. Think of zeros as 0, 0, or 0, 9. Then I go to the next number and restart, go through all the sequence all over again. So 0, 1, 2, 3, 4, 5, 6, 9. The next number it's 1 and 0, and so forth. So 19. And after 19, I'm gonna go to the next number, which is 2. Then go to the whole sequence again. Those 20. And once you get to 99, it's the exact same thing. So this is already over. So it's already taken. So what I'm gonna do is add another number. So this is the sequence of a decimal. Let me point this out over here. But now let's look at the binary. It should be 0 and then 1, and we're gonna do the exact same rules that apply to the decimal. So you already had 0, already had 1, then you go to the next sequence. It's 1, 0, and then the next it's 1, 0, then it's 1, 1. Oops, go back up, and then pretty much like 100. From the 99 to 100, you're doing the same thing, and then go back to the same sequence: 0, 1, 0, 1, 0, 1, 1, 1, and then 0, 0, 0. Exact same thing, but over here we have less. It's a base 2 system, so you only have 2 counting characters to work with. And here we have 10. It's a base 10 system. Now hexadecimal, it's exact same. So 0, 1, 2, 3, 4, 5, 9, and then you have A, B, C, D, and to F, and then we go through the whole sequence, and then the next value will be the same thing. So not 0, 1, but 1. Then it will become 10. So 10 is not really. And then after we go to 19, it becomes 1A. And then 1F. And then 2, 0, and so on. The exact same system. All of this all correspond to the same rules that we've all been using. So this includes the decimal, and then we have this extra letters to correspond in the other 5 values of this. Point an arrow over here. What I think about hexadecimal is that people say that decimal was really invented because humans have 10 fingers. That's how they started counting with. So if somebody actually had 15 fingers, there'll be extra, some other characters to represent this number. It'll be base 15, but all of this is follow the exact same rules for everything. And now octo, which is pretty much the exact same. So 0, go through 7, and then go through 10, and then last value 17 and 20 and so on. So that's pretty much gonna cover it. I hoped it was a better material to understand than the last time. And I'll see you guys in the next video.